You know, from H.G. Wells all the way to Back to the Future, the idea of a time machine, well, it's just captivated us for over a century, right? We all dream of hopping in a machine, maybe visiting the past, or taking a quick peek at the future. But is that all it is? Just a dream? Or is this something that science is actually working on? Well, let's dive in and find out.
So let's just get the big question out of the way right up front. Is time travel just something for the movies? Well, the answer you get from modern physics is it's kind of complicated. And honestly, it is way more fascinating than you probably think. What we're about to unpack here might just completely change how you see time itself.
Okay, so before we can even begin to talk about traveling through time, we got to get on the same page about what time even is. Because for physicists, it's not just the tick-tock of a clock on the wall. Oh no, it's something much, much bigger.
Right, so this is where our everyday experience of time just gets thrown out the window. Thanks to Albert Einstein, we now know that time is literally woven together with the three dimensions of space, creating this single cosmic fabric called space-time. And just like a sheet of fabric, it can be stretched and warped by really massive things, like stars, or by traveling at ridiculously high speeds. The big takeaway here is that time is relative. My now isn't necessarily your now. Wild, right?
Okay, so if time isn't some straight, unchangeable river, but it's more like this bendable, flowing fabric, then the next question is pretty obvious, isn't it? Can we navigate it? Can we actually travel to the future?
And the answer to that is a resounding yes. And look, this isn't some theory or a wild guess. There is one scientifically proven, tested, and totally confirmed way to travel through time. And get this, we've already been doing it for decades. It's all thanks to a little something called time dilation. It's a core piece of Einstein's theory of relativity. To put it simply, speed and time are connected. The faster you blast through space, the slower the clock ticks for you compared to someone just chilling back on Earth. This isn't fiction. Astronauts on the International Space Station are living this every single day. They are literally living just a tiny, tiny fraction of a second in our future.
And this isn't even up for debate. Time dilation is 100% real. In fact, the GPS satellites that you use every single day have to constantly correct their clocks for it, otherwise your maps would be useless. So traveling to the future? Yeah, we've already cracked that code. The only thing stopping us is building a ship fast enough to make a really big jump.
All right, so the future is possible. We got that. But what about the real holy grail of time travel? What about going backwards? Now we're moving into the much more speculative and honestly the much more exciting world of theories for visiting the past.
So this whole journey into the past, it really stands on the shoulders of giants. It all kicks off with Einstein, of course, whose equations kind of blew the door open. Then you got people like Rosen, who helped dream up wormholes, Tipler with his crazy huge rotating cylinders, Alcubierre, who gave us a warp drive that works, at least on paper, and even modern physicists like Ronald Mallet, who are still pushing these ideas forward today.
First up, the sci-fi classic, the wormhole. You know it. It's officially called an Einstein-Rosen bridge, and it's a theoretical shortcut through the fabric of space-time. And here's the absolutely wild part. Hundreds of mathematical solutions for wormholes already exist inside Einstein's own equations, so in theory, they're completely possible.
But, yeah, there's always a catch, isn't there? To keep a wormhole propped open long enough for something to actually get through, you need this stuff called exotic matter. This is totally theoretical material with negative energy density, which basically means it has anti-gravity properties. Thing is, we've never seen it, and we have absolutely no idea how to make it. So that's a problem.
Okay, next up, the Alcubierre warp drive. Now this is cool. Instead of trying to move through space, the idea here is to move space around your ship. You'd basically be surfing a wave in the space-time fabric, squishing it in front of you and stretching it out behind you. From inside your little bubble, you wouldn't be breaking the speed of light, but to anyone watching, you'd get to your destination faster than a beam of light could.
And you guessed it, here comes the catch for that one. The energy you'd need to power this drive is, well, it's staggering. We are talking about the energy equivalent to the entire mass of the planet Jupiter. Oh, and yeah, just like the wormhole, it also needs that same pesky, totally theoretical exotic matter.
And hey, there are other ideas floating around too. The Tipler cylinder could work, but you'd have to build a cylinder that was infinitely long and spinning impossibly fast. Dr. Mallet's laser ring might be able to twist space-time, but the effect would probably be so tiny you could never even measure it.
And quantum tunneling?
Yeah, that works, but only for like single particles, not for you or me.
So you're probably starting to notice a pattern here, right?
Every single theory for traveling to the past runs smack into a few gigantic, seemingly impossible walls. Let's just break down what those ultimate roadblocks really are.
So yeah, there are 4 great walls. First, the energy problem. All these ideas need the power of a star or that exotic matter we don't have. Second, the scale problem. Some of these machines would literally have to be the size of a galaxy. Third, the stability problem. The machine could just collapse into a black hole the second you turn it on. And fourth, causality. This is the big one, the paradox problem. Even if you built one, most theories say you could only travel back to the moment the machine was first switched on. So sorry, no visiting the dinosaurs.
Whew, that all sounds pretty daunting, doesn't it? So after looking at the proven science and all these wild theories, let's just ground ourselves for a second. What is the actual, practical verdict on time travel in our world today?
Okay, let's just look at the final scorecard. Traveling to the future using speed and time dilation, that's real. It's proven. Done. Using the insane gravity of a black hole to do the same thing, theoretically that should work too. Wormholes? Well, the math checks out, but the engineering is completely, totally beyond us. And actually traveling to the past? Well, most physicists are going to tell you it's extremely unlikely, if not outright impossible.
But science is always moving forward. Dr. Ronald Mallet, who is one of the physicists actually working on these problems, he stays pretty optimistic. His view is that we're really just at the very beginning of understanding these forces, and what seems totally impossible to us now might just be commonplace for our grandkids.
And that leaves us with the final question, doesn't it? We've gone from science fiction to proven fact, from mind-bending theories to these enormous challenges. We know traveling forward in time is real, and we know the path to the past is blocked by walls we just can't seem to climb. Yet. So, how close are we really? I guess the journey to find out is what science is all about.